Hello everyone, I am Kyoung-Hee Kim, a professor of architecture. This video will be discussing the promote aspect of sustainable facade systems. In our framework, Protect, Promote, Regenerate, Protect in the previous video discussed the fundamental functions of building enclosures as a shield to protect humans, buildings, and nature. In addition to this essential protect function, promote refers to how the building envelope further enhances the indoor environment for healthy and well-being occupants, nature, and the building. In other words, beyond just protecting us from harsh or dangerous environments, a well-designed facade promotes occupant comfort, health, and experience. Modern facades are not merely cosmetics. They perform multiple functions and respond to environmental and technological demands rather than serving as just an ornament. Building skins actively interact with users to create thermally, visually, and acoustically comfortable environments. They go beyond basic protection and contribute to sensory experience as well as health and well-being. Thermal Delight in Architecture by Lisa Heschong is a good reference for understanding how the indoor environment created by sustainable facades can become a source of meaningful architectural experience rather than merely a technical requirement and ornament, and how building skins can promote occupant comfort through thoughtful environmental design. On this slide, we see an overview of the three functions of sustainable building envelopes: protect, promote, and regenerate. Detailed explanations are available in the Sustainable Facade System introductory video. To highlight, protect refers to the envelope's role in protecting the building, occupants, and nature from harm and weather, ensuring the basics of safety and durability. Promote focuses on enhancing indoor environmental quality for occupants. A promoting facade maximizes natural daylighting while controlling glare and providing views to the outside. The building enclosure can enable natural ventilation and ensure good air quality, thereby promoting health and well-being. If the facade integrates natural elements, such as living wall systems or microalgae windows, it creates biophilic qualities and aesthetics that improve the user experience. We will look at a case study and discuss how high-performance facades can make indoor spaces more pleasant and healthier to be in. Regenerate represents the highest function of regenerative facades. This involves the facade actively contributing back to the environment or generating resources for construction and building operations. That can mean generating renewable energy like integrated solar panels or renewable biodiesel feedstock, sequestering carbon through plants' photosynthesis, or even collecting and filtering rainwater through vegetation-integrated facades. A regenerative facade turns the building skin into a producer of resources, not just a consumer. Note that these functions aren't isolated. A single facade system can offer all three, but conceptually, this breakdown helps ensure we're addressing the triple goals: protecting and promoting the health and well-being of occupants, nature, and the integrity of buildings, while regenerating environmental value. As we explore promote, keep in mind that a sustainable facade must excel at providing comfort and delight for people inside while still meeting those protective duties for nature and the built environment. This slide illustrates two areas of design science principles in an architectural space: thermal design science on the left and luminous design science on the right. Apertures and opaque walls should be designed to utilize surrounding resources such as sunlight and air movement to improve thermal and luminous experiences while reducing energy consumption for heating, cooling, ventilation, and artificial lighting loads. Thermal design science refers to how we design the facade for heating, cooling, and ventilation performance. For instance, insulating against heat loss, preventing overheating from sun, and allowing fresh airflow when needed. The phrase skin thermal loads is noted here to emphasize that the building skin carries the burden of these thermal and daylight exchanges. In this diagram, we see internal thermal loads, things inside the building that generate heat, such as occupants, lighting, computers and equipment, cooking areas, elevators, and other miscellaneous sources. These everyday internal activities and appliances release heat that can warm up the interior. On the exterior side of the room, we see external factors like solar radiation, sunlight hitting the facade, and air infiltration through outside air leaking in. All of these contributors' internal gains and external gains or losses sum up to the thermal load that the building skin must manage. Luminous design science refers to designing for daylight and visual comfort, admitting enough natural light to illuminate spaces, but controlling glare and contrast so that the daylight is useful, not bothersome. The building section illustrates how daylighting could be enhanced through facade design. The size and placement of the aperture affect the quality and quantity of daylight entering the room. Because the sunlight is constantly changing, a good daylighting design aims to bring enough natural light while effectively controlling glare wells. Essentially, energy is constantly flowing between the outdoor and interior space, and the facade mediates that exchange. It is important to address both thermal and luminous design simultaneously. If you focus only on thermal insulation but ignore daylight, it might end up with a dark, gloomy interior. Conversely, a glass wall gives great daylight and view, but might cause overheating or glare if not properly designed. The takeaway is that a sustainable facade requires an integrated approach, balancing multiple performance aspects to promote a high-quality indoor environment. Finally, visual access to the outdoors plays a critical role in enhancing user experience. Connections to natural views are positively correlated with increased productivity and reduced stress levels. Clear visual content through apertures should be intentionally designed, not merely as daylighting elements, because the interplay between view, light, space, and surrounding environments significantly contributes to a positive user experience. Let's look at a real-world example of a facade that promotes indoor environmental quality and enhances user experience. The Populus Hotel in Denver, Colorado, designed by Studio Gang, is 135,000 square foot and 13 stories tall, housing 265 hotel rooms. The building is enclosed with striking facades. As you can see from this exterior image, the building facade is composed of hundreds of curving scalloped window openings, almost like oversized, eye-shaped leaves covering the building. The design motif of the Populus Hotel project is the Populus tree. The trunk has a distinctive texture, where the dark oval marks on the bark are the marking of old branches that once grew and later removed. This represents the tree's natural adaptation to its environment. In addition, the horizontal markings are lenticels, which serves as a tree breather, enabling oxygen and carbon dioxide gas exchange and helping internal cells stay alive when leaves photosynthesis is not effective. This inspires the concept of architectural skin as an environmental exchanger, the architectural surface that mediates between the interior and the outdoors, much like the tree's bark. In addition to biophilic aesthetic, there is a deliberate facade design strategy to connect inside and outside. At the base of the building, large arching storefront windows. These are about 30 feet high and multiple modules create dramatic portals that welcome people into the lobby and restaurant from the street. Each of those vertical scallop modules located in upper floors is actually the width of a single hotel guest room, which shows how the facade's rhythm is directly tied to the hotel's room layout and function. This slide shows the elevation and facade typologies for the Populus Hotel facade. The design incorporates a range of modular openings, each shaped and scaled according to the interior program and location within the building. In the top diagram, Micro-unit windows serve more private programs, whereas the bigger modules serve public gathering on storefront and rooftop restaurants. The bottom diagram shows the unfolded facade, revealing the full variations of different facade typologies. Looking at the unfolded facades, we can also identify building programs behind the facade module. Taller and wider modules are located on the ground and rooftop levels, and narrower units enclose micro-units of the hotel rooms. This unfolded elevation reinforces both functional zoning and visual expressions similar to the Populus tree bark. In hotel rooms, the windows become more human-scaled and even occupiable. The facade design creates cozy window nooks where guests can sit within the thickness of the facade, almost like little balconies or window seats inside the room. Curling up in the window bay and having an immersive view of downtown Denver and the Rocky Mountains provides a special experience for guests. The shape and size of the oval windows respond to the sun's movement. The eastern and western apertures integrate protruding shading device or extended eaves along the perimeter, blocking the sunrise and sunset light and reducing glare for the rooms. The protruding shading device along the top of the southern windows block the high-angle sun. They also help channel rainwater away from the window openings and divert to a certain collecting location. This slide breaks down the construction and assembly of the three-dimensional window aperture used on the Populus hotel facade. Unlike flat window systems, these apertures are sculpted volumes, formed by a structural frame and curved cladding panels that extend outward to provide both shading and visual depth, and project inward to create a seating, occupiable space. On the left, you see the geometry of a single unit. The recess creates a sculpted window nook that modulates sunlight, offers privacy, and channels rainwater away from the opening. At the top right, the exploded axonometric shows the layered assembly, a main and secondary substructure supporting a cast GFRC, glass fiber reinforced concrete panel system, labeled here as Aspen Eye panels, bolted to the main frame. This GFRC cladding wraps around the aperture, giving it its characteristic form and texture. At the bottom right, the fabrication diagrams illustrate a prefabricated unit composed of the substructure and cladding before installation. This prefabricated system ensures accuracy in geometry and quality control during assembly. Overall, the design of the aperture is not just aesthetic, it acts as an integrated shading element, environmental buffer, occupiable threshold, and a tactile, expressive skin that contributes to the identity of the building. This final slide presents a bird's-eye view of the Populus Hotel overlooking downtown Denver. The Populus Hotel's rooftop offers panoramic views of Denver. This space not only provides leisure opportunities, but also integrates green design elements. The building stands as an iconic addition to the urban skyline. Its sculpted facade was inspired by Colorado's natural environment, specifically the Populus tree. It's a building designed not just to be seen, but to perform, to inspire, and to connect people, architecture, and nature. This video was supported by UNC Charlotte in collaboration with the US-ASEAN Smart Cities Partnership. For further inquiries, please contact Kyoung-Hee Kim at UNC Charlotte. We appreciate your interest in sustainable architecture and look forward to future collaborations.